Hello, you are most welcome. I'm teacher Ivan from Wuna Educational Services, welcoming you to our second lesson of linear motion. In our first lesson, we looked at how we derive the equations of a uniformly accelerated motion, and now we shall be looking at the applications. Where and how do we apply these equations in solving mathematical problems? Our example 1 says, a car moving with a velocity of 10 meters per second accelerates uniformly at a rate of 1 meter per square second until it reaches a velocity of 15. They want us to calculate time taken, the distance traveled during the acceleration, and the velocity reached 100 meters from the place where acceleration began. So this is how we are applying the equations to solve this problem. The first step always when you are given calculations in physics, the first step is to summarize. You summarize the information given from statement to mathematical forms. So in the question, we are given a car that is moving with 10 meters per second. 10 meters per second is now our initial velocity, and now this one is accelerating uniformly at a rate of 1 meter per second squared, so that is acceleration 1 meter per second squared until it reaches a velocity of 15. That velocity is v, 15 meters per second. So they want us to calculate the time taken. So if you look at our equations, the first one being v equals to u plus at, the second one s equaling to ut plus a half at squared, and the third being v squared equals to u squared plus 2as. Now, which one is suitable for this particular problem? Look at what you're given and compare with what the equation needs. If we look at the first one, we have v, we have a, we have u, and a, we want t. So I think the first one is the most suitable, because in the second we don't have the displacement, neither the time, so we can't use that. In the third, we don't have time, and it's time we want, so we need to use an equation which has what we are looking for. So you find the first one the most suitable for this, and therefore we say from v equaling to u plus at, we substitute and get what we need. V is 15, u is 10, a is 1, and t. Hence giving us 15 equaling to 10 plus t. And therefore 15 minus 10 gives us the time. So that time is 5 seconds. Seconds is small s, or you can write the word seconds. Avoid writing the word sec. Sec is something very different in science. So that will be our time. We had the other parts. Part B was asking for the distance traveled during this acceleration, meaning they want us to get displacement. So we can use either the second or the third. Since we have time, we can use the second, and since we have v, u, and a, we can use the third. I would prefer using the third. So we say from v squared equaling to u squared plus 2as, we substitute. V is 15 squared equaling to u squared, which is 10 squared, plus 2a is 1 and s what we want. So this gives us 225 equaling to 100 plus 2s. So when this one crosses the equal signs, it becomes 225 minus 100 equaling to 2s. So that gives us 125 equaling to 2s by 2 by 2. That displacement is 60. This is 62.5 meters. So that is the distance that is covered. And then lastly, they want us to find the velocity reached. Velocity reached 100 meters from the place where acceleration began. So if we are to look at velocity reached, we are considering our displacement s as 100 meters. We are considering u, which is 10 meters per second. We are considering a as 1 meter per second squared. And therefore, we don't know the time it takes this car to cover 100 meters. And since we want the final velocity v and we don't have time, therefore we should use an equation where time is avoided, and that is the third equation, which states that v squared equals to u squared plus 2as. So we substitute and find v. That is v squared equals to u, which is 100. If we square 10 plus 2 into 1 into 100. Therefore, that gives us v squared as 100 plus 200, which is v squared equaling to 300. So that velocity reached is the square root of 300, which is simply 10 root 3 meters per second. So that is how we shall solve such a calculation using the application of the equations of a uniformly accelerated motion. Then our second question, we are told that a particle, in our second question, we have a particle moving in a straight line with a constant acceleration of 2 meters per second squared, is initially at rest, meaning u is 0 meters per second. They want us to find the distance covered by the particle in the 3rd second of its motion. Wow, this is quite interesting. So this one is moving in a straight line. Let's say it is from point A. During the 1st second, this is when time is 0. During the 1st second, that's when time equals to 1 second. It covers some distance. During the 2nd second, that's when time is 2 seconds. It covers some distance. And during the 3rd second, when time is 3 seconds, it also covers a distance. So we are asked to find the distance covered by the particle in the third second. So this is the third second. And therefore, this distance that is asked can be got by getting the total distance, and we take away the distance during the second second. And therefore, that can be achieved by getting S3 minus S2. So we get S3, which is UT3 plus 83, this is a half but squared, minus UT2 plus a half 82 squared. You find that we have some common factors, which is U and A and a half. So that can't stop us from working out. We can continue and substitute. U is 0 plus a half, A is 2, then the T3 is when it is covering its third second, minus, this is squared, minus 0 since U is 0, plus a half into 2, then T2 is when it's covering the second second, so that is 2 squared, which will give us, this we can reduce that and that to give us 9, minus, we reduce that and that to give us a 4, and therefore that distance is 5 meters. So that means that it covers 5 meters between the second second and the third second. That is how we deal with the equations. We have another number, that's number 3. We are told that a traveling car A at a constant velocity of 25 meters per second overtakes a car which is stationary, that is car B stationary. Then after 2 seconds, car B sets off in pursuit, accelerating at a uniform rate of 6 meters per second squared. They want us to find how far does B travel before catching up with A. Please, I would love you to try out this, but as you are trying out, just know that between the second car and the first car, there is a difference of 2 seconds. You can try out that, and the answer you must get is 300 meters. That should be the answer you get. Otherwise, I request to pause from here. I will come you to our third lesson of linear motion. Please, you can always comment with your answer so that we discuss together and share ideas.